In a hydroelectric power plant, electricity is produced from water. A dam is built across a large river to hold back the river water and raise its level to form a reservoir. At the bottom of the dam, there is a floodgate. Water flows through the penstock and rotates the turbine. The flowing water rotates the turbine, which is placed at the end of the penstock. The turbine, in turn.
Electricity is a form of energy resulting from the existence of charged particles, such as electrons or protons, either statically or dynamically as a current.
Particles can have a positive charge or a negative charge. Particles with the same charge repel one another. Particles with opposite charges attract one another. This is because charged particles create electric fields. And electric fields exert a force on charged particles. When there is an electric field between 2 points, we say that there is a voltage between them. Voltage can be thought of as the height of a mountain. Rocks at higher elevations can do more damage. The same is true with voltage. The height of the mountain tells you the energy of each falling rock. The total power is the height of the mountain times the number of falling rocks. Similarly, the voltage is the energy of each charged particle. The total power is the voltage times the number of particles. The number of particles is called the current.
Ohm's law states that the current through a conductor between 2 points is directly proportional to the potential difference across 2 points. Electric power is the rate at which electric energy is transferred by an electric circuit. The power formula is P equals V times I. P standing for watts, I standing for amps, and V standing for volts.
This is an introduction to the importance of electromagnetic induction. If you ever drove a car, you will know the motor of an engine relies on all sorts of fields, one being the magnetic field, which in fact rotates the coil itself. The engineering behind this motor is heavily reliant on magnetic fields and currents. In fact, all substances respond to the magnetic field, even us. Magnetic fields also give rise to currents, which we can predict the direction of using Fleming's left-hand rule. The first finger being the magnetic field, a second finger being the current, and a thumb being the thrust, the motive force. So how does a coil rotate in an engine? Here's a brief example, but with a wire instead. If we were to take a wire which has a magnetic field going into the plane, which can be seen by the small crosshairs, and we were to physically move that wire downwards, then a current will flow to such as to oppose that force. In other words, a current will flow that will tend to cause the wire to go in the other direction to oppose the force that's causing the current in the first place. Which means if you use the left-hand rule, you've got the force going upwards, the resistive force, and the field going inwards, which will mean the current will flow to the right. It
is important to understand that a generator does not actually create electrical energy. Instead, it uses the mechanical energy supplied to it to force electric charges present in the wire of its windings through an external electric circuit.
A power supply is an electronic device that supplies electric energy to an electrical load. The primary function of a power supply is to convert one form of electrical energy to another.
Electrical current is the flow of charged particles, or specifically, in the case of AC and DC, the flow of electrons. According to Carl K. Bergen, professor of electrical engineering at MIT, the fundamental difference between AC and DC is the direction of flow. DC is constant and moves in one direction.